All right, so today we're going to start Chapter 7, Part 2, and we're going to start with Component 4, which is verifying trigonomic identities. So an identity is a statement of equality between two expressions that is true for all variables. Okay, so one thing that's really important is that we have our trig identity sheet. So if you were in class, I printed this for you. If you were at home, you can look at the very home page of Outcome 7 Part 2. There's a big button that says click here. If you have the possibility, then I would suggest you print that at home or just have it up on your Chromebook. So when working with identities, the really important part is that we're working with one side of the equation at a time. Okay, so we're going to start with either the left side or the right side, and we're going to work with that side until it makes the other side. Okay, you always want to start with the more complicated side. Okay, some things to watch out for: we're going to be factoring, we're going to be adding and subtracting fractions, we might need to get some common denominators, we might be squaring binomials, etc. I would look for opportunities to use basic identities such as sine or cosine, secants, cosecants, all those kind of things go well together as well. Just keep in mind that if preceding steps don't work, try changing all the terms to sine and cosine. That's always a good step to make. If you get through and you start to realize that this is just getting worse and worse and worse, then it's probably best to just start over. Okay, these types of problems, just try something. If you're gonna sit there and stare at your paper for 20 minutes, nah, you're not getting anywhere, okay? I will warn you right now, get a good eraser. We're gonna start some of these problems and then you're gonna have to erase and start completely over, and that's okay. If you're not willing to do that, then you will not do well on this unit. You really have to be able to try something, it didn't work, cross it out, try something again. Okay, don't just sit there and stare, that's not gonna get you anywhere. Okay, I like to think of these as you're starting someplace and you're trying to get to the other side. Okay, so for example, if I was at the school and I wanted to go home, right, I'm gonna get in my car and I'm gonna start driving. Now, every way to get home, there might be multiple ways for you to drive home, right? You could pull out of the parking lot and turn left onto Game Farm Road, or you could turn right onto Game Farm Road. If you usually turn left to get home, that's probably the fastest route to get home, but that doesn't mean you couldn't turn right onto Game Farm. You could turn right onto Game Farm and just have to go around 47 to 34. It's going to take you longer to get home, but it's not wrong to take that longer route. Okay, so think of these as you're driving home. Sometimes you take the long route, but as long as you get where you're trying to go, it doesn't really matter if it took you longer or not. Okay, so for example, on our first problem, we want to prove that sine cosine times cosecant equals cosine. Okay, so essentially think of this as we're starting here and I'm going to drive, and this is my home. So this is where we're starting, and I want this to get us home to cosine. Okay, so you always want to start with the more complicated side, like step 1 said. So if we look here, the left side in this problem is more complicated. So I'm going to start by the left side. So the left side is sine of x, cosine of x, cosecant of x. Now notice I didn't write equals cosine. Okay, I'm only starting with the left side. Okay, you're not worried about this. This is just getting you home. So if I'm starting with this, I'm going to complete some math and I'm going to be nice and organized. And then eventually I want to write equals, and I just want it to be cosine. So we're going to use some math to help us with this. Okay, so one nice thing to do, like it says here, is try changing all the terms to sine and cosine. So I'm going to write sine is sine x over 1, because that's already sine. Then I'm going to write cosine. I'm going to write a little multiplication sign. Now cosecant, remember, goes with sine. So cosecant is 1 over sine of x, right? You can also notice that here on our sheet, cosecant equals 1 over sine. So I'm going to change all of them to sines and cosines. Okay. Now if we look here, we're going to see if we can do any kind of math so that I can get to just cosine of x. Well, remember, when we're multiplying fractions, we multiply straight across, and when we're multiplying, we can cross things off on the top and the bottom. So if we look here, I have a sign on the top and a sign on the bottom, so I'm allowed to cross those out. Now keep in mind, you're only allowed to do that if it's multiplication. If this was addition, we're not allowed to do that. So now on the top I have cosine times 1, which is just cosine of x. And then I have 1 times 1, so that's just 1, so this gives me cosine. Oh look, cosine is the right side, so now I have the left side equals the right side, so now I'm done with the problem. Okay, so it's a very simple first example. Let's look at example 2. So we're going to look here and we're going to say, well, which side looks more complicated? Well, in this problem, the side that looks more complicated is the left side. So I'm going to write that down. Sine squared x tangent x plus tangent x cosine squared x. Now remember, there's lots of ways that we could get home, right? You could turn left or right onto Game Farm. Either way you can get home. So there's lots of steps that we could take here. Personally, the first thing that I notice is that we have a tangent in either side of our plus. Now remember, if we have something that's the same, we can use our algebra skills, our factoring skills, and know that we can factor out a GCF. So that's where I'm going to start. I'm going to factor out this tangent of x. So if I factor that out, that leaves me with just sine of x, sine squared of x, and cosine squared of x, because I factored out the tangent, right? Just like if I had x squared plus x, we're allowed to factor out an x, which would give us x plus 1. It's the same concept that we're doing there, but with tangent of x. So now that I've gotten this far, if you notice, I have a sine squared and a cosine squared. Whenever you see a sine squared over a cosine squared, you should think to yourself, I'm going to look at my Pythagorean identity sheet. Well, if I look here under my Pythagorean identities, sine squared plus cosine squared equals 1. So if I know sine squared plus cosine squared equals 1, then that means I can change this entire statement to just be 1. So that gives me tangent of x times 1. Well, tangent of x times 1 is just tangent of x. Well, now that's my right side. So now the left side equals the right side, and I'm complete. Okay, let's look at some more problems. Number 3. Show that secant of x plus tangent of x equals all of this. Okay, so if you notice in these problems, I said left side equals, right? So I was kind of giving you a hint. We should start with the left side. You're not always going to start with the left side. You're always going to start with the more complicated side. So if I look in this problem, I would actually say the right side here is more complicated than the left side. So I'm actually going to start this time with the right side and try to make it look like the left side. So I'm going to start with the right side. So the right side here . So there's the right side of the equation. So there's a couple different things we could do here. We want to look for, maybe we want to change these into sines and cosines. Okay, so in this side I have sines and cosines. Here I have sine, but in this one I have secant. So let's change secant into cosine. Okay, another thing that you might notice is, remember in the last problem I told you, whenever you see a sine squared or a cosine squared, you should think I should look at my Pythagorean sheet. So if we look here, I have sine squared plus cosine squared equals 1. Well, let's think about this. If I were to subtract this to the other side, I would not write this on your sheet, by the way. That would get me cosine squared all by itself. So that would give me cosine squared x equals 1 minus sine squared. We're allowed to do that. All that is manipulating the problem, right? That's like having y equals mx plus b. We're allowed to move the b over if we wanted, right? You can rewrite equations all the times that you want. So all I did was move the sign to the other side. Now we could do the same thing. If I wanted to do the opposite, if I'm like, oh, I want to know what sine squared equals, I'm allowed to subtract cosine squared to the other side. So that gives me sine squared x equals 1 minus cosine squared. Now all three of these then all mean the same thing, They're just in different orders. All we did was manipulate the math. So if we look, I have here 1 minus sine squared. Well, 1 minus sine squared equals cosine squared. So I'm going to change this whole thing here to be cosine squared, because 1 minus sine squared equals cosine squared. So that gives me cosine of x over cosine squared of x plus sine of x, and then we can change secant. Secant is 1 over cosine. Now that's a times 1 over cosine x. All right, so now that we've gotten to this step, let's start looking at what we could do. Well, here I have a cosine over a cosine squared. So that's just like saying x over x squared. If I had x over x squared, the x's could cancel and that would give me 1 over x, right? Because I have one more x on the bottom than I do on the top. So same thing here, I have one more cosine than I do on the top. Notice how I'm going down. I ran out of room, so I'm going to use an arrow and move over here, right? I'm nice and organized. You can follow my thoughts. If I can't follow your thoughts on a quiz or test, then I'm not going to give you points. You can't write something here and then write something here and then write something here. It's got to be all nice and neat. You got to follow your work. So if I'm going to cross that out, I'm going to have a 1 on the top and a cosine on the bottom, right? Because I have no more cosines on the top. I had 2 of them down here, so all I'm left with is 1. Plus, now when we multiply fractions, we multiply the top and we multiply the bottom. So I've got sine x times 1, which would just be sine x, and 1 times cosine x. Now remember, we have to keep in mind, where am I trying to go? Okay, am I trying to go home? Am I trying to go to the store? Am I trying to go to Walmart? Like, where am I trying to go? So keep in mind that I'm trying to make this into this. Now, if this was no plus, I would say, oh look, I've got common denominators. I should probably add these fractions together. However, if we look here, I have a plus sign in my left side, and we have a plus here, so I don't want to add these fractions because I want there to still be a plus on the left-hand side. So if we think 1 over cosine, well, 1 over cosine is equal to secant. So I can change 1 over cosine here into secant of x. Then if we look, tangent of x is sine over cosine. Well, this is sine over cosine, so that is the tangent of x. Oh look, that is the left side. So now I've made the right side equal to the left side. So I'm done. Okay, here's my suggestion to you. We've got example 4 and example 5 here for you to do. My suggestion is to pause the video, try example 4, try example 5. Okay, check your answers online. If you are stuck and you don't know what to do, then unpause the video and you can watch me explain these, but I would like you to try to do them on your own before you listen to me. Okay? So pause and try them on your own. If you get stuck, come back to the video. All right, so in number 4, we're going to start with the more complicated side. So I would say the more complicated side here is the left-hand side, and I'm trying to make that look like the right-hand side. So I'm going to start with the left hand, which is 1 plus tangent squared over cosecant of x, secant of x. Now remember in these other problems when I said whenever you see a sine squared, in your brain you should be thinking, I need to go to the Pythagorean theorem. Same thing here. If I see a 1 plus tangent squared, let's go to our Pythagorean theorem spot here. If we look, tangent squared plus 1 is equal to secant squared. Well, this is tangent squared plus 1, so this whole thing here can turn into secant squared. And then on the bottom, I've got cosecant x and secant x. Oops. So now secant and secant squared can cancel because I have 1 on top, 1 on bottom, so that gives us secant of x over cosecant of x. Well, we know too, I'm going to see how I'm being nice and organized. I'm saying my next step is going to be over here. Well, we know that secant is 1 over cosine of x. And we know that cosecant is 1 over sine of x. So then that's 1 over cosine of x times, whenever we divide fractions, we don't divide, we say multiply by the reciprocal. So I'm going to change this to multiply instead of divide by the reciprocal, which is sine of x over 1, which then gives us 1 times sine of x is sine of x. Cosine times 1 is cosine of x. Well, let's look. I'm trying to make this tangent of x. Well, we know that sine of x over cosine of x is tangent of x, which is the right side, which means we're done. Okay, number 5. I would say the left side here is more complicated. When I see this, the first thing I think of is, if I look on the right-hand side, there's no parentheses, and I have parentheses here. So let's get rid of the parentheses. And in algebra, when I'm getting rid of parentheses, I distribute. So that's my first step. You guys might try a different step. Maybe you think, I want to get these to turn into sines and cosines instead of secant and tangent. You're welcome to start there. For me, I'm going to start with just distributing. So that's what I'm going to do first. So I'm going to take secant of x times 1, which is secant of x times tangent, which is just secant of x times sine of x. And then we have negative tan x times 1 would be negative tan x. And then we have negative tangent times sine, which would be negative tangent times sine. So now that I've distributed, I distributed the secant and I distributed the negative tangent. Now I'm going to go through and change all of these to sines and cosines. You could have changed it first and then distributed. Me personally, I wanted to distribute then change, but it's totally up to you. So secant is 1 over cosine. Secant is 1 over cosine. Sine stays the same, so I'm just going to put that over 1 to help us. Tangent is sine over cosine. Tangent is sine over cosine. And then sine here will stay a sine. Okay, now keep in mind, we're allowed to multiply fractions, and when we're multiplying, we're allowed to cross things out, but when we're adding or subtracting, we're not. So let's look at just the multiplication things we've got going on. So these two things are being multiplied. We've got addition or subtraction between all the others. So I'm going to leave this as 1 over cosine plus, here we've got sine times cosine, excuse me, 1 times sine over cosine times 1, which gives us cosine over sine. And then here, sine over cosine minus, and then we've got sine times sine, which would give us sine squared. And cosine times 1, which is cosine. There is a difference, guys, between sine squared of x and sine x squared. Make sure the squared is not here, but rather with the sine. You're not squaring the angle, you're squaring that it's sine times sine. Okay, you saying sine of x squared is saying you're doing sine of x times x. Sine squared of x is saying you're doing sine of x times sine of x. Those are two different things. This is not what's happening in the last problem. It's that we're doing sine times sine, so it's the sine that's squared, not the x that's squared. All right, well, if we look, sine over cosine minus sine over cosine cancels out, right? That's like saying 1 minus 1 is 0, so those are gone. Now we have common denominators here, so when we have common denominators, we're allowed to add our fractions. So we have 1 minus sine squared on the top, all over cosine. Now remember, I told you whenever we see a sine squared, we should look over here. 1 minus sine squared is cosine squared. So 1 minus sine squared, I could change that to cosine squared. over cosine. The cosine and the squared could cancel. We have one more cosine on the top than we did on the bottom. So that leaves us with just cosine, or cosine over 1, which is just cosine of x, which is the right side. So we're done.